Myself Pandit Santosh. Today subject instrumental methods for chemical analysis. Unit number 1, that is introduction. Bit number 3, that is classification. Classification of instrumental methods focuses on how the instrumental methods are classified. So what is the base behind the classification? So all these we'll discuss in detail. You need to inculcate these PO1 to PO12. So instrumental methods are classified by the type of analytical techniques. Which techniques has been used, whether it was classical technique or instrumental techniques. We have discussed previously that classical methods are the methods which are performed in a lab. Gravimetric method, volumetric method, burette, pipette, titration. These are the mediums by which the classical methods are performed. Whereas instrumental methods make use of instruments with their physical laws and they carry the experiment with the help of microcontrollers, that is automation. So whether the sample was analyzed by classical method or instrumental method. Second, by the nature of generated data, whether the measurement was done on a single channel or multi-channel. When the samples are more, we go for multi-channel measurement. At a time, n number of samples are being tested, that is multi-channel. Then by the quantization method, it means by the analyte concentration was calculated by absolute method or relative method. Absolute method means analyte concentration is calculated directly from the measurement of sample. For example, sample is present, we are passing source of light. Source of light interacts with the sample and from the transmission light we are able to predict the contents of the sample. So it is called as absolute method. Whereas in relative method, we go for use of standard. Generally, double distilled water is being used as standard and the analyte interaction, the analyte results are compared with the results of the standard. That is called as relative method. So this slide focuses that it may be the type of analytical techniques or it may be type of measurement data generated or absolute method and relative method. Is determined, whereas in titrometric method the volume or mass of a standard reagent which is required to completely react the analyte is measured and that gives the information regarding the analyte. Classical methods is based on precipitation, extraction, distillation. Methods, they are based on measurement of physical properties of the analyte such as conductivity. Each analyte is having its own properties, its own resistance. So inverse of resistance is conductance. Each analyte produces varying potential, so it becomes electrode potential. Each analyte is having its own absorption coefficient. Each analyte means molecules of the analyte has its own emission coefficient. Each molecule of the analyte is having its mass and its charge. So depending upon the mass to charge ratio of that atom molecule, we are having separation, fluorescence. Each atom goes to the excited state depending upon its own characteristics, comes down and emits light of varying wavelength. So these are some of the physical properties on which the instrumental methods is classified. Instrumental methods are further classified by the principles by which the measurement signal is generated. On what principle the measurement signal is there? That first is electrochemical method. Now electrochemical means they are the redox reaction. If we take a mango juice and you put it two electrodes, and after some time you'll find that the redox reaction has been started, and that redox reaction will give the information regarding the contents of the juice. Second is spectrochemical methods of analysis. Now spectro means it is the interaction of the source with the matter. So here the electromagnetic radiations interacts with the analyte. Then we have mass spectroscopy. In mass spectroscopy, the analyte is being ionized. The sample is converted from one form to ionized form, and then from the ions, the concentration of the sample is predicted. Then we have amperostatic coulometry. Coulometry means it basically concentrates on the coulombs. How much electricity was consumed in order to completely react the analyte. So here we observe that that these are the principles by which the measurement signals are generated. Spectroscopy basically means interaction of the molecules with the electromagnetic radiation. So if the radiation is ultraviolet, it becomes ultraviolet spectroscopy. If the radiation is infrared, it becomes infrared spectroscopy. If the interaction undergoes absorption, it is called as atomic absorption spectroscopy. If it undergoes emission, it is called as atomic emission spectroscopy. Same thing we have photo emission, means input is photo and we have the emission from it. It becomes photo emission spectroscopy. Then we have Raman spectroscopy, where instead of absorption emission, the interaction causes scattering phenomena. So that becomes Raman spectroscopy. Then in nuclear magnetic resonance, there is, instead of scattering, they focus on the rotation of the molecules. And when resonance happens, then the sample absorbs the radio frequency, gets excited and tells I am present. Then we have X-ray fluorescence spectroscopy. Means X-ray, with the help of X-rays, the fluorescence phenomena is produced. So in this way, we have seen that there are various types of instruments which are on the basis of their physical properties of the analyte. They are undergoing various phenomena. Analysis are divided into three categories. First is spectral method, second is electroanalytical method, and third is separative methods. In spectral method, it analyzes according to the type of property of acid substance. Means which property of the analyte was undergone in the phenomena. For example, whether there was a absorption, whether there was emission, there was scattering, there was diffraction, there was refraction, like this. So spectral methods basically concentrate on the interaction of the electromagnetic radiations with the matter and the phenomena which happens. Second is electroanalytical methods. Here name only suggests electroanalytical, means we are applying input as electricity and output also we are getting electrical properties. From the output electrical properties we predict the contents of the sample. For example, if we apply voltage and we get current, then output current is proportional, we give some information about the sample. Like the case is voltammetry. Third is separative method. Here a normal sample is being bombarded with some electrons or X-rays and the sample is converted into its ionized form, and from that ionized form we are predicting the qualitative and quantitative information of the sample. So thus the instrumental methods can be summed as spectral method, electroanalytical method and separative methods. This table, in the first column we can see that there are signals, emission of radiation. So when the phenomena is emission of radiation, the instrumental methods becomes fluorescence, phosphorescence, luminescence. When the signal, when the phenomena is absorption of radiation, then it becomes absorption spectroscopy, photometry, spectrophotometry. When it is scattering of radiation, it becomes Raman spectroscopy, nephelometry, turbidimetry. If the phenomena is undergoing refraction, then it becomes refractometry, interferometry. If it is diffraction, then it becomes X-ray diffraction methods. If it is rotation, then it becomes polarimetry. If we are analyzing the sample and the potential is being generated spontaneously, so it indicates that method is potentiometry. Without applying anything, we are getting the potential, so the term becomes potentiometry. If the same thing is carried out with a constant current, it becomes chronopotentiometry. Then if it is electric charge, the signal, then it indicates that the instrumental method is coulometry. Coulometry means coulombs, unit of electricity, means how much unit of electricity, means how much electricity was consumed in order to completely react the content of the analyte. Then electric current, we have amperometry. If we are measuring the current, it becomes amperometry. Electrical resistance, so each molecule has its own resistance. So based on this resistance, inverse of resistance is conductance. Mass to charge ratio, every element has its own mass, own charge. So based on mass to charge ratio, they get separated and they tell I am there, and in how much I am amount I am there. Next is rate of reaction. Every element reacts with different rate. Then thermal properties. Thermal conductivity. For example, if someone is drinking tea in a saucer, so let's imagine two people are drinking tea in saucer, and to both the saucer air is blown, but one air contains large amount of oxygen and one air contains large amount of carbon dioxide. Now the same air is passed with the same flow rate, but the rate of cooling of tea will be different in both the saucer, because both the oxygen and carbon dioxide, they are having different thermal properties. The rate of cooling the tea will be different. So these such thermal properties we'll see. Radioactivity. So in our syllabus we'll be concentrating on scintillation counter, proportional counter, Ziegler-Muller counter. So I hope that in classification you have got the base, that spectral method, electroanalytical method and separation methods. These are the three base on which the various instrumental methods are classified. And this table tells that depending upon the signal, we have the various instrumental methods.